So hi everyone, my name is Raja Soorya from Department of Computer Applications. Today I am going to take the topic normalization in DBMS. So in this session you will learn about what is functional dependencies and the relationship between different normal forms and how we prevent the data anomalies and the unnormalized tables can be decomposed into normalized tables. So these are all the things we are going to learn in this session. So first we see what is normalization. So it is a process for minimizing data redundancy in the set of tables or relations. So if it is redundant, it may cause insertion, deletion and update anomalies. So anomalies means a confusion that takes place when you insert the data or delete or update the data. So here we will see the types of normal forms. So there are 5 types of normal forms and additional BCNF also there. So first we will see first normal form. So in the first normal form, the main condition we want to see that is the attribute, if it is contain multi-valued things, it is not in first normal form. So for example, we take this table. So in the first table, you see that for the student phone number, for the student ROM, there are 2 phone numbers. So for the attribute student phone, we have 2 values. So it violates the first normal form. So we decompose the table into, see the second table, for ROM we can decompose into 2 tuples. So first tuple, first phone number, and for the second tuple we take the second phone number. So in this way we will decompose the unnormalized table into normalized table for the first normal form. And next thing, second normal form. So in this second normal form, the condition is a relation must not contain any partial dependency. So before we see this, we'll learn about prime attribute and non-prime attribute. So a prime attribute is an attribute which is a part of candidate key. So for the relation, we will take some attributes as candidate key. So the attributes that placed in the candidate key is called prime attributes. Remaining attributes that is not placed in the candidate key, it is a non-prime attribute. So we'll see the second normal form example. So you'll see the first table. So in this table, the primary key attributes are student ID and project ID. So because we take student ID and project ID as candidate key, so it will include in prime attributes. So remaining student name and project name are non-prime attributes. So see the functional dependency. The student name can be determined by student ID and project name also can be determined by project ID. So here it takes the partial dependency. So it violates the rule of second normal form. So we decompose the table into 2 tables. One is student information and another one is project information. And next thing, third normal form. So in third normal form, if there is any transitive dependency in the relation, it violates the rule of third normal form. For example, if the functional dependency y dependent on x, x must be the super key and y is the prime attribute. So already we know that prime attribute, it is an attribute that is the part of the candidate key. So see the example. In this table, we'll list out the super keys first. So employee ID alone the super key, and employee ID and employee name also a super key, and again employee ID, employee name and the zip code together we take it as super key. So from this one we will list out the candidate key. So employee ID is the candidate key. So in this one, employee state and employee city, it is dependent on employee zip code, and the non-prime attributes employee state and city, it is transitively dependent on employee ID. Why we say this as transitively dependent? because the employee zip code is dependent on employee ID only. So from this thing we will say that it is transitively dependent on employee ID. So we will decompose the given table into two tables. So first table employee ID, name and zip code alone, and in the second table zip code, employee state and employee city. So next thing is BCNF, that is boys code normal form, and a relation if it is in 3NF and also functional dependency, that is Y dependent on A, X must be the super key. So if X is not a super key, then it is not in BCNF. So here we see the example. In this table, first we take the candidates key. So candidates key to student and teacher, we will take a candidates key, and student and subject also a candidate key. So and below the table you see the functional dependency. So first dependency is subject is dependent on student and teacher is dependent on student and subject is dependent on teacher. So first two functional dependency, it does not violates the rule for BCNF. See the third functional dependency, already we know that if Y dependent on X and X must be the super key, it is in BCNF. So here X is teacher, and teacher it is not a part of super key, so it violates the rule of BCNF. So we want to decompose this table into two tables. First table teacher and subject alone we take it as first table, and second table student and teacher. So now it is in BCNF. And next one is fourth normal form. A relation if it is in fourth normal form, first it must be in BCNF, and also it does not have any multi-valued dependency. So from this example we can take that in this relation student ID 21, it contains two courses maths and computer and two hobbies dancing and singing. So it is a multi-value dependencies on student ID. So it leads to unnecessary repetition of data, and also it violates the rule of fourth normal form. So we want to decompose this table into two tables. In the first table student ID and student course, and second table student ID and hobby. So it is in 4NF. And next one, fifth normal form. So a relation if it is in fifth normal form, first it is in 4NF, and also when we join the tables it does not lose any data, that is joining should be lossless. So fifth normal form is not also known as project join normal form. So we'll see the example. So in this table, the problem with this table is that all the three columns together we take it as primary key, because student name alone we cannot take it as primary key, and student course, student professor also we cannot take it as primary key. So if we take these three attributes together, it is a primary key. So when you add a new data in this table, if you place null values in any of the attributes, it is not acceptable for the primary key. So it violates the rule of 5NF. So we want to decompose this table into three tables. First one, student name and student course in one table, and student course and professor in another table, and student name and professor in another table. So in these three tables does not violate the rules of 5NF. So that's all. These are all the types of normal form. So first normal form, no multi-valued attributes there, and second normal form, no partial dependency, and for third normal form, no transitive dependency, and for BCNF Y dependent on X means X must be the super key, and for fourth NF it does not have any multi-valued dependency, and for fifth NF it does not contains any joint dependency. So from this we learn about the types of normal forms in normalization, and why we are using normalization, and what are all the ways to decompose the unnormalized table into normalized tables. So thank you.